All right, friends, here we go. So we're on 2C.14, log function context and data modeling. So basically, we're going to be taking our information that's given to us and turn it into log functions. So up first, you have here the average salary for a church pastor across the U.S. increases based on the church size, right? The graph shows how this changes. And as you can see, it is an exponential change. Not exponential, a logarithmic change. See the shape of it? You can follow that. We can see that it's making the shape of a log. You want to be a pastor now? But look how many people you have to be pastoring over in order to get to that, right? So just as we have before with linears, quadratics, exponentials, we're going to create log function models, okay? So for a given set of data, if the input values appear to change proportionally, which means that the input is changing by a multiple of something, right? Proportionally, there's a ratio taking place. Then the log model is appropriate, okay? A log function models the form y equals a plus b natural log of x, or y equals a plus b log x, okay? Where a and b are constants, all right? Notice that when we're doing log models, we're either going to be using natural log or common log. We're not going to worry about the base. We're going to either be using natural or common. Got it? All right, so here we're going to talk about how to do it by hand, and then I'm going to model it using a graphing utility, okay? By hand is not terrible. By hand, I think is more satisfying personally, but that's just me. I could be weird. So we have a table of data here, and we want to show that is represent L of n x equals a plus b natural log of x. And we want to use this given data to write the two equations that represent. So our first equation is going to come from using our first given points, 2 and 3. Okay? So 2 and 3 are going to be our x and our y in this model. Okay? So we're going to have L of 2, which equals, we don't know A, we don't know B, natural log of 2, and the output is going to be 3. That's going to be our first model. Then we're going to create our second model using x equals 5. So we have L of 5 equals, we don't know A, we don't know B. We're going to plug in 5 for x, and that equals 7. Now, we're going to use systems to solve for A and B. So we're going to create a system. So creating a system, go with that color. We're just going to line them up. So we have A plus B natural log of 2 equals 3. And then we have A plus B natural log of 5 equals 7. Yeah, section B. It says now we're going to find the values of A and B, and we do so by creating a system. Okay? When we create the system, we're going to actually subtract our values. By subtracting our values, we then are going to start solving for our A and for our B. So if I subtract, I'm going to multiply everything down here by negative. So this is going to become negative A minus B natural log of 5 equals negative 7. Do y'all remember solving systems where you multiply by a negative so that you can cancel out? What ends up happening here is that my A's are going to do what? My A's cancel out. And we're now left with B natural log of 2 minus B natural log of 5 equals, what's 3 minus 7? Negative 4. Because they both have a B, I can factor out B. When I factor out B, I'm left with the natural log of 2 minus the natural log of 5 equals negative 4. What do I need to do to get B by itself? divide by the natural log of 2 minus the natural log of 5. So I'm going to divide both sides by that. I'm just going to do this because I don't want to, I'm running out of room. So we're going to take this and plug in the calculator and get our approximate b value. Our exact b value is -4 divided by the natural log of 2 minus the natural log of 5. We're going to find our approximate value using our handy dandy calculator. Let me pull up old girl Sylvie because she can stay on the screen at the same time, whereas Desmos doesn't act right. Second plus 7, 1, 2. I have -4 divided by, because I can't make the fraction, I have to use parentheses to protect my numerator and denominator, the natural log of 2, close parentheses, minus the natural log of 5, double close parentheses, and hit enter. And I get that the approximate value is 4, and let's round to the nearest, 3, 6, 5, 4. Is that? That's good enough. 4 decimal places. So now that I have my B, can I solve for A? Yes, Ms. Jones. Once you have your B, you can solve for your A. Yeah. Because if I know the value of B, can I plug into either one of these equations and solve for A?
Yes.
Yes. Does it matter which one I use?
No, it does not matter.
It does not matter. So I can now solve. I can minimize it. Okay, so now I'm going to solve. I'm going to choose one of these. Which one you choose is totally up to you. I just usually go with the smallest numbers. Does that make sense?
Yeah.
So I'm going to take this guy right here, and I'm going to plug in and solve for B, I mean for A. So I know that A equals, and B is A equals, and what I'm going to have to do to this whole thing?
Yeah,
subtract it equals 3 minus 4.3654 natural log of 2. Because that's what I would have to do to get A by itself. Yes. So I'm going to plug this in the calculator. Now, when we're using the calculator, we actually want to use the original value to get a better answer. So when I type in 3 minus, so I have 3 minus, I'm actually going to insert this. Does that make sense? What the actual value is. So to do that, I'm going to control, and then I'm going to go up and grab. That allows me to put the exact value in for B. I said control. I didn't mean control. Arrow up. Yeah, and hit enter. And it allows you to put the whole thing. The key thing is I protected it. I put it in parentheses. So I'll do it again. So I typed in 3 minus parenthesis, and I want to get as close to value as possible. So I'm going to go up, hit enter, close it, and now I'm going to type in natural log of 2.
Question?
Yes.
So why'd you put 4.3654 with LN2?
Because that's the value of B. The approximate value of B was 4 and 3,654, 10,000.
Is there a when you exit out of tab, then there's an arrow, make it smaller or squeeze it out? Oh, that's much better. Oh, yeah. Is that supposed to be 3 minus something?
Yes, it's 3 minus.
You just sort of answer if you like don't put into the equation at the top of the answer right below.
If their numbers are close, yes. Okay, hit enter. And we get, especially if you are rounding to more decimal places, or inserting that, because then it's going to still do it. I just play it safe and put the whole thing. But yeah. All right. So we end up with, it's approximately negative 0.28. I'm gonna put 8. I'm rounding to the nearest 4. All right, so now I have A. Now I have B. Can I write the equation? Yes. So my model, L of x equals, what's your A? Negative 0.0258 plus your B, which is 4.3654 natural log of x. And that will be your model. Now, yep. Yeah, I was just putting it all together for you. It just asked for what's A and B, but I wanted to put A and B back in their place. On which part?
On the 3 minus, I could just ask for more columns, say this for columns. Because it really is for columns. Oh, that's what.
And like Tasharmi said, if you don't want to grab that, you can do 3 minus. And you can just go up and grab the result as well, because it's pretty long decimal anyway. Make sure you put it back in its parentheses, natural log of 2. And I'm still going to get relatively the same thing. You see that? It's a little bit off at the end because I didn't use the exact, but you can see that relatively it's the same thing, right? The first 4, when you truncate it, it's going to be the same. All right. Now, we know that I do absolutely love Sylvie and her children and her grandchildren. However, I will say that I will give props to Desmos for when doing regression models. So we're going to actually be doing this using Desmos because we've done plenty regression models using our handheld. And I just want to make sure that we are comfortable using the Desmos as a tool. All right. Also, the reason why I like this is when you have larger tables, to me personally, it's faster to type them in than have to press them on the calculator. Okay. However, your call, but I'm going to model it using what? Desmos. Okay. I have my table in front of me, so I don't have to keep going back and forth. So, yes.
Yeah, I still get confused. You know, how to type it in, because I keep getting like, I don't know how to get that question.
Which part?
For A.
For A?
When we're solving for A, we're doing on the calculator for some reason. I keep getting like 8 or 10 instead of that.
Are you putting it in exactly how I've put it in?
But that's what I was trying to do, but I couldn't see.
Yeah, it's just a matter of putting in. All I did was go, find my B, then I grab it, plug it in, and I make sure I put it in parentheses. And then continue on writing the parts that I need. But that's what it is. Okay. So where were we going? Desmos. Okay. Again, I encourage you to follow along with Desmos. So we're going to start inputting these values into Desmos. So in Desmos, I'm going to add a table. I'm going to input my table values, and I'm going to do it quietly because I feel like you don't need me to read it out loud to you because you have the numbers on your table, and it helps me. Huh? You're going to be inputting the values into Desmos? What were you doing? I said, Max, focus, please.
Okay, stop it. I keep getting this. Yeah. Sorry. I don't want.
Your original is wrong. That's the problem. So your calculator you used to use the feature to make a different fraction. Because you using parentheses isn't working for you, but you have the feature to make it into a fraction. The alpha variable, it's gonna allow you to create that fraction. So it should be, what was it? I forgot already, but. No. Before you go talk about outer range, you should be worried about that. So when you're putting this in, it's -4 over natural log of 2 minus natural log of 5. You're putting in a fraction. That's what your problem is. You're inputting your fraction incorrectly. So when you have 3 minus that times the natural log that you didn't write of 2.
Who the heck is a super mega church of 5,000 people?
Mega churches.
Scammers.
Yes, you need to use your fraction feature. All right, so now that we've done this, everyone's put their stuff in. Okay, we're now going to find the regression model. To find any regression in Desmos, it's going to be y1 tilde a plus b natural log of x1. And we have to make sure we check the log mode box. Everything's all lowercase. Shift the button next to 1. The tilde.
How do I get down below?
I don't know what you mean. Arrow down? Scroll down? You should it'll automatically put itself. This is natural log, LA. Yeah. I was like, what is it? Natural log. All right, so here's our natural log regression model. I do not see it, but if you go back to here where it says zoom fit for your table, it'll zoom in itself.
Oh.
Okay. So if you go there, so again, all I did was come over here, up here to my table. You see that magnifying glass? That's our zoom fit. I click zoom fit and it's going to show me the points and it's going to show me the function model. Yes.
Kind of equation.
Natural log.
No, yeah, but like you didn't use like linear quadratic or anything.
No, I use natural log.
Okay.
A plus B, natural log of X. Yes. If you're going to stick to handheld.
I like Sylvie.
Sylvie, I told you I love Sylvie and our children. It's just that when it's a larger set of data, it does go a lot faster for me to just type it in versus me pressing it on here because I don't have it in my hand. Does that make sense? You know what I'm saying? Yes. But Hudson's going to be our proof. We're going to get the same values either way. Okay. So whether you run it this way or that way, what's going to happen? Same graph, same function is going to take place. What you do have to remember when using Desmos is to check that log mode. Okay. Make sure you do what? Check the log mode. Okay. Now, once you're here, in order to be able, the beauty about Desmos, about TI-84 is once I put it in the function and I save it as Y1, I can now interact with it, right? However, for Desmos, you have to type it as a function in order to see the complete table, okay? So, putting in the complete table, I have f of x equals, and I literally just copy and paste. Like, I'm going to come up here, hit Control-C, Control-V. Plus, I've copied and pasted my A value. Now I'm going to copy and paste my Control-Copy and can paste my B value. And then I'm going to type natural log of X. Okay, what that allows me now to do is to actually interact with the function. I can now pull up the table. I can now find values. I can now analyze at any point. Does that make sense? Unless you put it in as a function, you cannot pull up a table in Desmos. And now you can put in your X values, right? So on our assignment, let's be on our notes. Let's go back to our notes. It says create your regression model, right? So use the regression capabilities of graphing calculator or whatever it is to create our model. So we created our model and we ended up with y hat. Y hat just lets me know that it's a regression model. Does that make sense? Y hat equals, and our A value was approximately negative 91, and I'm going to write 54242 plus our B, which is 29, and I'm going to go to 29.9088 natural log of x. Now that I have a model, can I answer their question? So it says, if I'm a pastor of 500 people, on average, what should I expect my salary to be? Well, that means we're now looking for y hat of 500. Okay, I can now go to my table on Desmos and pull that up, right? If I go back here, because I've already put in my function, I can now type in 500, and my estimated salary is, to get the table. So you remember where we copied and pasted and created our model? Once you've done that, oh, I'm going to do it again. It's fine. I know. I said, don't worry. I copied and paste, and now when I click here, I'm going to get the gear option, and it's going to say, do you want your table? And I can click on my table. Okay. And I'm going to type in 500, and it says, here's the value. I also can do it without a table by just typing in F of 500, F of 500, and it's going to give me that value also. I can look in a minute. Okay. How do we feel about doing this in Desmos? Doable? Yes. So we ended up with roughly, how much would they make? 94 and some change, right? We're going to put 32,950,000 dollars. Okay. I'll see what I have to see what you typed in. All right. Questions so far about using Desmos? No?
Can you go back to the FX?
Which part, babe? So all I did was copy and paste my A and my B values. It's just ln of x, yes, because that's the function model. Okay. So I copied and then I
It's like that, right?
That's what I do.
What's wrong?
I go outside and I leave.
You can change these. You have to change these values.
Oh, okay,
Yeah.
okay.
Those are yeah.
I thought you put on
Let me see. Did you check the log box? Okay. Oh, because you put I in, not ln. How did you know? All right, Ray, let me see what your error is. I looked at
Yeah, dude.
Don't say that. Don't be. I'm sorry. May you please
Just say the time's
refrain.
not right.
May you please refrain. I don't like
Just on your.
I don't like when you touch me.
Weird.
Stop.
You may proceed.
Alberta didn't do that to you. That's it. Stop.
That's you.
Imagine you're gonna bully and you say stop.
All right, so we're good with natural log regression. Yes? All right. It wasn't terrible. It was not. All right. So now we're going to move on. So it says here, the best common and preferred method to measure sound intensity levels is in decibels. The sound intensity level beta in decibels of a sound having intensity I in watts per meter squared is modeled by beta I equals A plus B log of I. So instead of using natural log, we're now using what? Common log. So instead of using natural log, we're using common log. So it says, the sounds of noise traffic has an intensity of 1 times 10 to the negative 5 watts per meter squared and corresponds to 70 decibels. A loud concert has an intensity of 1 corresponds to 120 decibels. Use the given data to write 2 equations that can be used to find the values, okay? Instead of using the given data, what we're going to do is we're going to actually use Desmos, okay? We're going to create a table of what's given to us and then use Desmos ourselves to find our A and B, okay? If I was to do it with the 2 equations, we would be creating a system again and then solving just what we did on example 1, okay? But we're going to practice taking a word problem, turning it into a table, and finding it from there. So, in terms of this problem, our I is our input, and our beta I is our output, right? So our intensity, our first intensity is 1 times 10 to the negative 5, right? We have 1 times 10 to the negative 5, and its output is what? 70 decibels, okay? At a concert with an intensity of just 1, its decibels are 120, okay? And we're going to use these 2 points to do a log. When you're putting log in, it's the exact same thing. So it's going to be y1 tilde a plus b, and it's going to be log of x1. It's going to be the same process. 1 times 10 to the negative 5. Okay, so I'm going to go over here, and I'm going to just start a new graph. I'm going to clear out my old stuff. Delete, delete, delete. You're gone. You're gone. You're out of here. Exactly. We don't want you no more. Gone. I'm going to add a new table, and I'm putting in 1 times 10. 1. How's it going to let me put it in here?
It's
Shift 8. I was like, which one is it? Thank you. Times 10 to the negative 5. I know. I was like, wait, I knew this. It's right here. Yeah, I didn't mean to do that. Good job. All right, and we have 70, right? And then at 1, it was how much? 120. Okay, so we've made our table. We're going to adjust the window. There it is. Now we're going to find our regression model. So our regression model, again, is going to be 1, y1, tilde, a plus b. And this time we're using what? Log, common log, L-O-G. Parentheses, x1, close parentheses. And notice because it's logged, it asked me to check a box. It's there. It's already in log. Okay, so do we have our A and our B values? It can be represented by a log function. Any 2 points can be represented by a log, an exponential, or a linear. You just got to pay attention to how they're growing. It should stay. Stat. Don't do that. Stat. So don't do that. It should. It doesn't have common log. Hudson, you would have to abandon ship because there's no common log. It's not logistics. There's no common log. It's only natural log.
Can you see if you can, after class, do you think you can see if you can?
If there's an update or something,
Well, no, it's like if you have to like press a different button.
I think you would have to program it in there, and I don't know how to program. But yeah.
That should be a simple thing that they can.
Well, I think because you can use the natural log and it's going to give you the similar results, that's why. They work the same, but not the same. One is based off of E and one is based off of tens. So if it's calling for a base of 10, which for this one it is because the intensity is and multiples of 10, I would think it would have to be common log. Yeah. All right, f of x equals. So again, I don't really need to copy this. I could just type 120 plus 10 log of x. Okay, how do we feel? Easy peasy. All right, so our A value equal 120, our B value equal 10. And so putting it all together, our regression model equals 120 plus 10 log of x. Okay, once I have a regression model, can I evaluate anything? So it says the human eardrum can burst when sounds reach an intensity level of 1 times 10 to the 4 watts per meter squared. According to the model found, what is the predicted number of decibels? So I now have my I value. So we're looking for beta when 1 times 10 to the 4. And we're going to use our y hat to find that. Make sense? So that means we're looking for y hat of 120. So I'm going to go to my Desmos. And I'm just going to type in f of x. But instead of x, I know what I'm looking for. I'm looking for 1, shift 8, 10 to the 4. And it tells me that that's going to be what? 160 decibels. So we end up with, this is 160 decibels is where our eardrums will explode. Yeah. I spelled decibels wrong.
I'm gonna play a little prank on.
And no one was going to tell me. All right. How do we feel? Are we feeling confident in about either using Desmos? Are we feeling confident about using our handheld to create the model? Okay. You have two methods. Hold on. You have two methods. You have by hand, which we showed first, right? Using systems. And then if you're like, oh, I don't know about systems, then you have it by calculator. Systems only works when there's only 2 given points. Does that make sense?
Yeah.
So system only works when there's given two points, but also solving using regression model also works with only 2 given points. Okay. So it's more of like, which do you feel most comfortable with and what's your preference? Cool. How do we feel about 2C.14? Not that bad, right?